Today we are going to talk on some of the conservative laws on physics. So first of all, we can discuss what is conservation laws. Conservation laws means they are the fundamental principles in physics that describes the conservation of certain physical quantities within a closed system. Some of the conservative laws are the conservation of electric charge, conservation of momentum, conservation of energy, conservation of angular momentum, conservation of mass, etc. So first we can discuss on conservation of mass. Conservation of mass means simply we can say that mass can neither be created nor be destroyed, but can only be changed from one form to another, where delta m, change in mass, is equal to 0, which means mass change equals to 0. There is no change in mass. It is applicable in chemical reactions, fluid dynamics, etc. Then we come to conservation of energy, which means we know that energy can either be created nor be destroyed, but can only be changed into one form to another. Delta is equal to 0. Next, some of the types of energy that are kinetic energy, potential energy, thermal energy, electric energy, etc. It is applicable in thermodynamics, mechanics, etc. Then we come to the conservation of momentum. Momentum P is equal to mass into velocity. The momentum can also which cannot be created or destroyed, but only be transferred. The momentum, there is no change in momentum, thus delta P, change in momentum, is 0. It's applicable in the time of collision, in the time of rocket propulsion, etc. Then we come to conservation of angular momentum. Angular momentum cannot be created or destroyed, but can only transferred. There also delta L is equal to 0. It is applicable in the rotational motions, orbital mechanics, where we use angles more on. Then we come to conservation of electric charge. We know that electric charges can neither be created or destroyed, but it can only be changed into one form to another, which is some kind of electric energy into mechanical energy. For example, the fan, the electrical energy into light energy, means the light, etc. It is applicable for electromagnetism, critic circuit analysis, etc. And then we come to center of mass system. It is the weighted average position of all particles based on the mass. It requires the collective position of the system for motion analysis, which means it is the point where the entire mass of the system is concentrated. If a body is taken, the center of mass is the place where the whole weight of the body is concentrated. ഒരു വസ്തു എങ്ങനെ ചലിക്കുന്നു അതുപോലെ മാത്രം ആ വസ്തുവിനകത്തെ ഒരു പോർഷൻ മാത്രം ചലിക്കാൻ പറ്റൂ. Then we come to the center of mass position, which comes under center of mass. There are center of mass position and center of mass motion. First of all, center of mass position is the average position of all the parts of the system weighting according to their mass. And the equations are given, where m is the mass, r is the position where the mass occupies, etc. Then we come to center of mass motion. The center of mass motion, as if all the mass of the system were concentrated at the point and acted upon by the net external force, where Cm is equal to Fx, which means total external Fext, which means the total external force on the system. The equation of the center of the mass motion can be written as where m1 we can take as m1, m2, mn, etc. are the masses, where r1, r2, rn, etc. are the position vectors. So mr is equal to say m1 r1 plus m2 r2 plus mn rn, which is the first equation. And then we know total mass is equal to m1 plus m2 plus mn. While differentiating the equation with respect to time, we take that m into dr by dt is equal to m1 d1 dr1 by dt plus m2 dr2 by dt plus etc. plus mn drn by dt, where momentum which means p is equal to mv, where mv is equal to m1 v1 plus m2 v2 plus etc. Therefore on differentiating it becomes dr by dt, where velocity, where v1 v2 vn etc. are the velocity of the particles, m1 m2 mn particles of mn. The velocity of m1 is equal to v1, velocity of m2 is equal to v2, velocity of mn is equal to vn. Therefore the differentiating the equation, we finally come into this answer, which is ma is equal to m1 a1 plus m2 a2 plus mn an. We are coming to the comparison between laboratory and center of mass systems. When we come to the both systems are two distinct reference frames used in physics to analyze and describe the motion of objects. A laboratory system is a non-inertial earth-fixed frame that considers gravity's influence, making it suitable for everyday phenomena and the experiment conducts on the Earth's surface. In contrast, a center of mass system is an inertial frame centered at the system center of mass, neglecting gravity or avenging its effects, which simplifies complex problem in celestial mechanics and high-speed applications. While when we come to the laboratory system, excels in measuring local effects and everyday phenomena. The center of mass system shines in calculating system dynamics and astronomical motions. Despite differences in gravity consideration, inertia and application, both systems rely on Newton's law and require precise measurements. Then the conservation of the center of masses. When we come to the conservation of center of masses, the main topics are momentum in center of mass and the energy which is conserved in the center of mass. The momentum of a system in the center of mass frame is defined as the product of the system where total mass and the velocity of its center of mass. We came to the equation thus p is equal to m into velocity of center of mass. P is equal to total momentum of the system, m is equal to total mass of the system, where p the momentum which is conserved can be calculated by mass into velocity of center of the system. Then we come to the energy in center of mass system. The energy of a system in the center of mass frame is defined as the sum of which the kinetic energy due to the kinetic energy which is formed due to motion, and the internal energy due to the internal interaction between the molecules or the particles. The type of energy in center of mass is kinetic, internal, potential and total energy.